Welcome, guys. Last session we spoke about queue theoretical part. What are the operations we can do on queue, like enqueue, dequeue, front, rear, and size and empty. These are the operations we spoke, and also we discussed about the time complexity of each operation can be done on the queue. So in this session, we'll see how we can implement a queue using C++. Right. So for now, what we will do is I will include IO stream for input output, and I will include, I think that is enough. We'll implement the queue using an array. Okay. Namespace std. Okay. We'll implement a queue class. Okay. So queue class we will have like a private section. We will implement uh, uh, integer like a front, sorry, int front integer rear. These are the positions basically, integer and integer array. So we will see like we can make the array size maximum some kind of 100. Okay. So basically we can define one const for that. Const int max size equal to assuming like some 100. Okay. I don't want to hard code this here. Max size. Okay. So these are the private sections. That this will be as I told, right, index of the front element, and the second one is index of the rear element, and this one we are using array to hold the queue elements. Okay. Now we'll make public section now. So we'll implement a queue constructor. Okay. So front equal to -1 and rear equal to -1. By default, the queue is empty, means we will try to use these two numbers are like -1, -1. Initially, we will try to write uh, is empty or full kind of operations, so that we will reuse in our enqueue and dequeue things. Okay. I'm trying to implement is empty function first actually. Okay. Is empty. This also, as I told you, this it's a time complexity to check. This is actually uh, is the queue is empty. This will take of one time complexity only. Okay, complexity only. Okay, so we'll return boolean variable is empty. When we can say is it empty if the front is actually equal to -1, right? Also, we will check the second thing also, is queue is full or not. Since we are maintaining uh, is full method to check the queue is full or not, because we are maintaining some fixed size, right? Max size in this case is 100 elements. Okay. It's time complexity also. will be O of one time complexity. Okay. Okay. So this is also very simple. Bool is full. Okay. Return actually rare equal to max size minus one. That's it. Now we'll try to implement our real functions Enqueue and all. Okay. Add element to the rear of the queue. This is what actually, right? So we already spoke about this here. This is what actually, right? This is the rear. When we are enqueuing, we need to add element here. In the previous theoretical session, we spoke about that. So now we'll see uh, enqueue. Okay, it will take integer data, whatever data you want to insert at rear. We'll just check if it is full. You can't insert anything, right? See out. I mean, like a queue is actually reached the maximum elements, like that is max size is 100. Then it is overflow, right? Queue is full, right? That's it. You can't return any. You can't insert any element at the rear. Just return now here. Okay. And if it is empty, then front is actually we need to make it 0. Okay. Because front it is empty means front should not be minus 1. Front should become 0, and because we need to uh, implement, right, rear plus plus. In case of the queue was empty, rear value was minus 1. Now with the, in case we are in inserting first element, then rear will become 1. Sorry, minus 1 to 1, it will become 0 basically. By default it is minus 1. Rear plus plus, it will become 0 at the first time first time when we are trying to insert element. Okay. Array of uh, rear equal to data. Okay. That's it about enqueue. And this operation, if you see, there are no loops, anything. We are directly accessing the rear position and we are inserting data. So it will take O of one time complexity. Okay. That's it about the enqueue. Let us see the dequeue. Okay. What dequeue operation will do? Remove element uh, element from the front of the queue, right? This is what this operation will do. Now void dequeue. So if you see this, in case of removing element from the queue, check it out if is empty. What if it is empty? See out, nothing to delete anything, right? Queue is empty. You can't do anything here because basically you can't delete any element here because nothing is there written from here. Okay. Otherwise, what we need to do is assume that if front and rear are same at the same position, that means both are at 0 0, right? Then front equal to -1, rear equal to -1. That means all elements are deleted from this. Okay. Else what we need to do? We need to front plus plus. You just increment the front position. That's it. That means that we are deleted the element from the front. Basically here, we are deleting element from here. That's it. Okay. Okay. So this operation also, if you see, we are not doing any loops or something. So this also will take O of 1 time complexity. Okay. Once Dequeue is done, then what we have is front and rear, right? Front. Okay. Front operation also is very straightforward. Get the element from the front of the queue. Okay. That is int front. You just check if the is empty or not. Okay. Queue is empty. Return -1. So we are returning the element, right? Front element. Okay. If this is not empty, it's very straightforward. Just array of front. We are not deleting any element in this operation. We are trying to return the front element. Okay. So this, if you see nothing, we are doing any loops or not anything. So its time complexity is O of 1. Okay. That's it about the front. What about rear? Rear also we just saw that get the element at the rear position of the queue. That's it. Okay. This also returns integer rear. Okay. In this case also you just see that is empty. Just see out nothing to return here also. Queue is empty. Okay. Oops. Okay. And return it here. Return from here only. Otherwise, it again straightforward. Okay. Uh, Again straightforward. Just return array of rear. So this operation also, if you observe carefully, no loops, nothing, it will also take O of 1 time complexity. Okay. Okay. Now we'll implement one last function for display purpose. Right. Okay. What we'll do is we'll try to display elements of the queue. Okay. So void display. So here, if you just check again, is it empty or not? Okay. If it is empty, see out queue is empty. Nothing to print anything here. And return from here only. Or else, what you need to do? Otherwise, what we need to do is we need to iterate actually. For teaser I equal to front, okay, I less than or equal to rear I plus plus. Okay. In this case, we are trying to print elements from the uh, queue, whatever queue we are using here. Okay. Okay. That's it about all the operations, and also we discussed about time complexities here. Okay. Now let us see how to use this object in our main function. Okay. Teaser main. Here we can create queue object queue q dot. We can see enqueue of one, q dot enqueue of two, q dot enqueue of three. Now we'll try to display this. Let us see what happens. Okay. Let us run this code actually. G plus plus. Okay, what is the error? Okay, 86. Oh, okay. In this case, we'll try to return -1. Let us see. In case of that, yeah, perfect. Now we'll try to run this code. Yeah, it is working. Let us see. If you see that elements are inserted in a enqueue, right? One, two, three, and we are displaying from front to rear, right? Okay. Now what operation we can do? We can try to do the dequeue now and try to. Actually, we see this expected output is this one right here. X expected 1, 2, 3. Now q dot will see the dequeue. Okay. Let us implement. Let us display now. After dequeue, what happens? Okay. So dequeue is supposed to be removed element from the uh, where it should remove element from the front, right? Front is what? In this case, 1. So if I run this, it should print 2 and 3. This is expected actually. Expected 2 and 3, right? Let us see that will work or not here. Right? So we are dequeued here so that it is removed from the front. Right? Now let us see that let us see like uh, let us try to get the q dot front. So front is actually we're expecting front is 2, correct? Rear is 3. Let's see what happens. So front is actually 2, right? Correct. Let us print cout q dot rear. Okay. Let us see this what happens. Right? Front is that and rear actually. Rear is 3. Right? Let us dequeue the two more times so that it will become empty. Q dot dequeue and q dot dequeue. So we are removed two here and three here, and we'll try to display. Q dot display is supposed to expect uh, Q is empty actually at line number 123. Okay. Okay. So we're expecting this one. Okay. Okay. That's it about the C++ implementation of Q with all operations. In next session, we'll talk about Golang implementation for the same Q.